Hello everyone, welcome to our channel Simple Physics and Chemistry. Today we will be discussing about a very important subject, that is de-Broglie waves. We will discuss about it and finally we will find out the expression for the de-Broglie wavelength. So before we start, let's memorize some history about the de-Broglie waves and its wavelength. So the first point is that we know that the particle nature of wave was discovered in 1905. So that is by Einstein during the photoelectric effect. He showed that a wave that is light can have its particle nature. But after that it took almost 20 years to realize that any moving particle can also have wave nature. That is, a particle have its nature as wave also. So that was found in 1924 when Louis de Broglie proposed that moving objects has wave and as well as particle nature. That is the wave particle duality. And in 1927 the existence of de Broglie wave was first demonstrated, and that was the key point because the wave particle duality became the starting point of the Schrodinger's successful development of quantum mechanics, so which is the modern mechanics for every phenomena that we discuss in physics and chemistry. Before we move forward to the video, please subscribe to our channel to get more videos on the relevant topics. So to derive the de Broglie wavelength, we need three things. The first thing is the Einstein equation, which is E is equal to mc square, where E is the energy of a particle, m is the mass, that is the rest mass, and c is the velocity of light in free space. The second equation will be the Planck's equation, which is E, the energy, is equal to h into nu, where nu is the frequency of that light and h is the Planck's constant, which comes from the proportionality of this relation E proportional to nu. Now we also know that c, that is velocity of light, is equal to nu into lambda, where nu is the frequency and lambda is the wavelength of the light. Now using 1 and 2, we'll have h nu is equal to mc square, and thus we'll get this h is equal to mc square by nu. Now using the equation 3, that is c is equal to nu lambda, we can come to this equation, that is h is equal to mc lambda. Now we can just rewrite this as lambda is equal to h by mc. So here c is the velocity of light. Now if we just use for some matter or for some particle, then it will have velocity v. So c will be replaced by its velocity v, and the equation will become lambda is equal to h by mv, but we know that mv is the momentum of a particle, that is p. So lambda is equal to h by p, which is the well-known de Broglie wavelength equation. Now we always talk about the wave particle duality, the wave nature of particle. Now let's see the wave of what? Like in every waves there something changes. Like in light, their electric and magnetic field changes with time. Okay. Now if you see some water waves, there the height of the wave changes with the distance. So here actually what changes? The changes here is the probability of having the particle in some particular time, or probability of having the getting the particle in some particular space. That is the probability. So probability of the particle's existence is the wave nature in the matter. So this gives us the matter wave. Please hit the like button if you liked it. Share if you feel it can help others. Subscribe to get new videos. Thank you and keep watching.